Good evening, everyone. Welcome to the webinar. Just doing a sound check here. So if my assistants in the background can hear me, they might just give me a message there and we should be good to go. We'll begin in the next 20 or 30 seconds. Okay, so I've got the all clear. So you're all welcome. This evening's webinar is going to focus on, I suppose, the subject of graphics, and we're going to look at different strategies that may be of particular use at this kind of strange time for all of us. So we're going to focus on digital learning activities this evening. The webinar will last approximately 60 minutes, so we should be all done by around 7:30. So during the course of tonight's webinar, we will outline various resources that are available to graphics teachers, and we'll do that by looking at our Junior Cycle for Teachers website, www.jct.ie. As I said, we're going to explore the use of digital technologies in the subject of graphics. And we're also going to collaboratively share experience of teaching graphics through remote learning. I suppose we're all experiencing it now at this stage with the different year groups, and we'll give teachers an opportunity throughout the webinar to maybe share with us through the questions tab different strategies that may be working for you that you might think would be useful for others to know. If you would like to ask any questions, or like I said, if you'd just like to give us any kind of comment at all, the questions tab is the best way of doing it on the GoToWebinar platform. So if you're on a laptop device or a computer, you'll have a kind of an interface that you can use, and you can type your question in there by just opening up on the orange arrow and using the questions tab to type your question. Your question can only be seen by the JCT staff. So I'll introduce everybody in a couple of moments as to who's in the background along with me. If you're on a mobile device or an iPad or a tablet or anything like that, if it's Android, your questions tab will be on the top of the screen. And if you're using an iOS device, the questions tab is just the opposite of that on the bottom. We'll be going to the website later on in the webinar just to show you where everything is, different resources, etc. But if you aren't familiar with it, in the technology section of jct.ie, we have areas for key documents, news and events, CPD workshops, planning, assessment, and resources. So I'll show you all of those later on. Now, this evening, we have John Kilgannon, who's an advisor for graphics, and John is joining us from Galway. We have John Forrest tuning in from Cork. We have the technologies team leader, Gerard Duff, coming in from Tipperary. And then myself, Michael Lynch, I'm an advisor for graphics, and I'm coming in from Longford this evening. So I'm hoping the Wi-Fi doesn't let me down. So the three lads in the background are going to be working on the questions. Towards the end of the webinar, we're going to give John Forrest an opportunity to come in, and he might share some of the most commonly asked questions, and also might be given an opportunity to share any kind of advice or strategies that are working for you. John will come in at the end and maybe share them with the rest of the audience tonight. Just to give you that opportunity, and I'm just going to get some stuff ready here while you're doing it. If you do want to start by typing into the questions tab on the interface, what methods or approaches are working well with remote learning at this time? It's a challenging time, but we've seen a lot of stuff maybe on Twitter, and we've seen teachers talking on different forums about what's working for them, or different kind of tips that they're picking up to help each other out. So if you have anything that you would like to share, you can put it in through the questions tab now or at any point during the webinar. And like I said, John may come in at the end and share some of those. So we're going to get down straight to it. A large part of tonight's webinar is going to be focusing on the use of Tinkercad. And we're exploring Tinkercad as just one option when you're maybe looking at computer-aided drawing with your junior cycle graphics class, particularly with the earlier groups, as it is quite a welcoming platform to engage with CAD in the first instance with. And we're just going to show the potential of it this evening. So one of the things we're going to focus on before we actually get down to modeling on Tinkercad is how you can structure your classroom groups on it. And we've picked up some advice actually from a teacher, Kieran Callahan, and we're going to hear from Kieran later on about how he's been using it. But really, we just want to thank him because the knowledge that we have around this actually came from Kieran initially letting us know about it. So we're going to go through the process of setting up a classroom group on Tinkercad Classroom. Just some kind of advice around that and to make life a bit easier for yourself. And also we'll show you how you can get kids to log in, etc., and just how to streamline it that way. Then we're going to come back and we are going to look at how the student would experience it. So I'll do a bit of modeling of an object that I have here beside me. And some of my fellow advisors in the background are going to do a bit of work as well. And we'll check in later on what they've been up to. So in Tinkercad Classroom, like I said, we're going to look at setting up our class group. We're going to look at how you can get students to log in, maybe the easiest ways to get them to log in, which doesn't require them maybe messing around with passwords or having to have accounts or anything like that. It's quite easy, so we'll just run through that. And also we'll look at the difference between maybe the teacher and the student interface, what a teacher would see versus what a student would see if they were associated with a classroom group. And finally, in the classroom part of it, we're just going to explore how students could work on things individually, but also there's a feature on Tinkercad which allows students to work on the same model collaboratively at the same time, even remotely. They don't need to be beside each other. So it works off the cloud-based forum that Tinkercad uses. So at this point, and I'm going to do this a couple of times during the webinar, I'm going to be on and off the PowerPoint, and I'm going to go on to my internet browser. So I use Google Chrome, but it'll work on any browser. And I'm going to switch over now, and I'm going to go to tinkercad.com. Now I'll be logged in already on this. Okay, and you'll see here when I log in, this is my interface here. This is like my home screen for Tinkercad. Now I've logged in, I've associated it with my Gmail account, but you can log in with anything. You don't need to be associated with one or the other. It's free to set up, etc. And when you do set up, when you want to set up a classroom as a teacher, if I go up to the top right-hand corner here and just look at where the profile picture is, and if I click that, my drop-down menu will open up. And you'll see here that one of the options here is classes. So if I click that, it'll open up my page for that. Now you'll see that I have one set up here. So this is a class that I set up earlier on around dinner time today, and I enrolled some students in it. So we're going to check in on that later on. But I'm just going to ask you how, or show you how to set one up from scratch. So they see this blue button here, create new class. I'm going to click on that. I'm just going to set one up just as a dummy class for the sake of just showing you. So I'm going to go JCT4 graphics webinar. Now you can associate an age profile and a subject profile with it. I won't go near that for now. I'm just going to click those as other, and I'm going to click create class. So you'll see here my webinar class has been set up, but there are 0 students enrolled in it. So I'm going to click into it and I'm going to start adding students. Now what I can do is I can add a student individually. So if I click on add students here, and I type in the name of a student, so I just put in my own name just for demonstration purposes. And you see, as I was typing it, Tinkercad was automatically generating what's known as a nickname. And that's what the student is actually going to need to use to get into your classroom group. So what it does is it just takes the first and last name, it bundles them together, puts it all in lowercase, and it finally puts a 4-digit code at the end. Now the 4-digit code is randomly generated. So if you are having maybe a lot of students in it, they'd all have different 4 codes. So what you can do is you can actually just change it manually. What I type in, generally advice I've got is if you type in the same 4-digit code for every student, it'll cut out a lot of confusion and them getting mixed up about what their username is. So if everybody has, let's say 2020 at the end, there won't be any messing with it that way. So if I click Save Changes, I'll now see that Michael Lynch is enrolled in that class. Now, I could keep doing that. I could keep adding and adding and adding, but I'd have to do it individually each time. There's a nice feature here which allows you to paste in a list of students. So I'm just going to demonstrate that now. So if I go to my desktop, I have a sample list made up here in Word, and I'm just going to copy down the list. So these are just some of the people that I'm working with at the moment, and I'm going to copy their names. I'm going to go back to my profile here, add students, paste a list of students, and I'm just going to paste those in. So you'll see down here now, it automatically has detected that there's 8 names there. So if I click add 8 students, you see here, I now have 9 people in the class, myself and the 8 that I just added. What you will notice though is that all of them have the random 4 digits at the end. So if I wanted to change that so that, let's say for instance, John Kilgannon didn't have to remember 1433 and Anthony Griffin didn't have to remember 2574 because I might get mixed up with them, I just changed them all to 2020. What I found out here myself is if you don't click the save button, the little floppy disk button, it'll revert back to the previous version. So just make sure and click that. So that's just to demonstrate it. I won't go down through them all, but you could just change them all. So their first name, last name, and whatever 4-digit code you want to use, like so. Okay, so that's how you set up a group. Now, how do the students get into it? Well, the benefit of this is that the students don't have to create their own account, and therefore they don't have to have an email address associated with it, like I have when I set up my teacher account, or they don't have to worry about passwords. All they need is their nickname. Now, what you will need to do is you will need to show them where your class group is. So you do that by generating what's called a class code on Tinkercad. So if I click that button, it'll generate it for me. And here I have a 12-digit code. Now, if I just copy that, like so, it copies it into my memory on the computer. And if I just go to a different internet browser where I'm not logged in, so I'm just going to go to Internet Explorer here, Edge as it's called now. And this is tinkercad.com. This is the home page if a student went here. And if I just go down here, you see this green button, join your class. So if I click there, I have to paste in that 12-digit code and then type in my nickname, and that'll get me in. But there's an easier way again. What I can do is, if I go back to my classroom here, instead of copying the code, if I copy a link and then share that with my students, so whatever way you share stuff, maybe you email it or maybe you have some sort of an online platform. If you share that link with the students and if they go directly to that link, the code is pre-typed in for them. So they don't need to worry about the 12-digit code. All they need to know is their nickname. So for instance, my nickname was my first name, my last name, and 2020. And Michael Lynch, the student, should be able to log into that classroom without having to worry about registering an account or without having to have any password associated. So you see here now, this is me logged in as a student in this fictitious classroom setting here that I've set up. So that's what it'll be like for students to set up an account. Now, you would have seen earlier on that I had a group set up earlier today, and it was called JCT4 2020, and there were 7 students in it. So those 7 students have modeled a little project over the last hour or so, just before we went live, and I'm going to show you those later on. Before I do, I'm just going to go back to my PowerPoint presentation, and we're just going to go through a little activity that we've set up for this evening. So in your handouts tab, if you were to open up that using your orange button, you'll see the handouts tab. And in it, you will find a handout to do with a Tinkercad engagement. So on that, we've just set up a little activity, and I'm going to mimic that activity now, where I'm going to take an object, deconstruct it, do a bit of sketching, and then model it on Tinkercad. And it could be something that may be of interest, maybe to first or second year groups at this particular time, something that they could do remotely at home. So the activity itself is grounded in the kind of fundamental structure of the graphics specification. And that's coming from the 3 strands and the 4 elements, the pillars of the subject as such: applied graphics, 3D graphics, and 2D graphics. And we've associated particular learning outcomes with the types of activities that we have constructed. In applied graphics, we're going to design ideas or solutions through modeling and prototyping, and we're basing that on an everyday object, and you'll see what I'm talking about in a moment. We're also going to use computer-aided graphics, in this case Tinkercad, and that's going to communicate our design. In terms of 3D graphics, we're going to develop our freehand sketching through 3D graphics. And I'm going to draw in 3D and think in 3D initially. And while I'm doing that, I'm going to focus on the geometry within the object. I'm going to look at the geometric principles behind how those shapes come about. And finally, towards the latter end, about a half an hour or so from now, we will then start to look at the 2D graphics side of things. And we're going to represent our 3D object in 2 dimensions using 2D drawing conventions. And we're going to do that with a digital technology. So that's all to come. So the first thing is sketching. And you'll find the handout in your handouts tab, like I said, but this is just a screen grab of a section of it. And what we're going to do is we're going to choose an everyday object. We're going to deconstruct it. And this was actually linked to one of the weekly challenges that we did with students that you may be aware of. I'll talk about those again later on as well. But we asked students around the country to take objects and to deconstruct them into 3D solids. What 3D solids, basic 3D solids, would the object be made up of, or could you build it from? And that's the kind of mindset we're going to use to go through this activity. I am going to pay attention, or try to pay attention, to proportion when I am sketching. And that's going to be kind of linking it back to the geometric principles of the objects that I'm focusing on. Okay, so what I'm going to do now is I'm going to switch over to the visualizer. I'm sure as we're all teaching remotely over the last few weeks, we know that technology can be our friend or our foe sometimes. So thankfully, yes, visualizer is active and is working. So the everyday object that I'm going to model, I just took this out of the fridge a couple of minutes ago, is a milk carton. And I just picked it up because I thought it would be something that everybody would have at home, or if not, something similar. So like I said, I'm going to start sketching it out, but what I'm going to focus on is the types of 3D solids that we can use in Tinkercad, and that's the ones we've laid out on the page. Now, that's not all of them, there's loads more, but this is just a starting block. So if I look at this milk carton, I see the main part of it here is a square-based prism. And I know that because if I check the measurement against it, I can see it's 70 by 70. So it's square-based. The height of it, in terms of direct perpendicular height, is 190. And then at that point, it begins to turn in, and it turns in a kind of a triangular shape. The last thing then in terms of the carton is it has this little lip on the top here, which again, if I look straight down, the front of it is rectangular in shape. And then an extra feature which I'll add in is the lid here, which is cylindrical. So if I was just to take my little worksheet here and just very quickly run through those shapes. So I said I have kind of a square-based prism, and I'm going to try and sketch in 3D. And I'm wary now that I have about 250 graphics teachers watching this, so don't judge me. So we're sketching in square-based prism. And like I said, I'm going to try and focus on proportion as I'm doing this. Like I said, the top of it then is kind of a triangular prism. And I could associate the lid of the milk carton as being a cylinder. So they're my kind of individual objects. To bring those together then, and what order they'll go in, well, obviously the main body of the carton is that square-based prism. It then goes towards an apex with the triangular prism. It has the rectangular lip on the top, and then it has the lid, which is cylindrical. So that's kind of a blueprint for me. And what I'm going to do is I'm just going to associate some measurement with that, and that'll be used as a kind of an instruction sheet when I go to Tinkercad. So like I said, the square-based part of it is 70 by 70. So I'm just making a very rough note of that. The perpendicular height of that portion of the milk carton is 190. It then has this triangular based prism which goes from left to right, and if I check the perpendicular height of that, it's about 25. Okay, so that's that part of it there. And then the lip on the top, I know from just checking before, it has about a height of 10 millimeters. Finally, the diameter of the cap is about 30 and it's centered on that angular surface. So I'm going to use that now as my blueprint. So if I go away from my visualizer, I'm going to go back to Tinkercad. And this is, I suppose, where we're going to start modeling. So if you ever want to jump back to your main interface or your home screen, just click the logo there. Now you see this is just some stuff I was working on before. Your stuff, all your files and your parts are all auto-saved. So they just save here in your home screen. So I'm going to go to create a new design. And when I'm modeling on Tinkercad, this is my workspace here, my work plane. Now, like a lot of cloud-based or browser-based CAD, the default view on this is fixed to perspective. So what I do, the first thing I do is I switch it back to a flat view, which is orthographic in nature. And that just helps me to line things up and make sure that certain shapes are aligned with each other. There isn't being perspective applied. So in the middle of the screen here, you'll see your work plane, which is the same sort of thing as your planes in SolidWorks that a lot of us will be familiar with. So that if what I'm going to do now is on the right hand side, this is where Tinkercad slightly differs to other CAD packages. And you see here is the reason I'm saying that is that you start in 3D. So as I browse down through my basic shapes here, you'll see that they're all pre-made for me. So I don't have to make a square profile and extrude it into a cube. I already have a cube. Now, to bring something over to your work plane, all you need to do is hold down on it and drag it over, and it'll rest on the work plane. It'll come in with predefined dimensions, and all you need to do to change those is to highlight the text box and type in whatever measurement you want. So remember now by just checking my sheet that the square base on the carton is 70 by 70, and the height of it is 190. Now what I'm going to do is I'm just going to zoom in here just to show you a little trick. In terms of height, there are two different buttons that you can press in Tinkercad. This one here with the white square refers to the height of the object. So that's the one that I want to change. There's also another one here, which is like a black cone or an arrow. What that refers to is the height that the object is off the work plane. So at the moment it's resting on it, so that would be 0. But if I wanted to elevate it up from that point, I could increase it by using that black cone or black arrow to change the measurement. I don't need to in this case. I'm going to change the height of the object to 190. And I press enter. Now you can see it's gone off the screen. So to zoom out, it's the same as with many CAD packages. I just use the wheel on the mouse. And if I want to toggle my view, I hold down the wheel and I can move the object around to suit where I'm viewing it or where I want it to go. So the next stage of building up this milk carton was to add in the triangular prism. And you'll see from the worksheet, these are the types of shapes we've kind of asked students to try and work with because they're here in Tinkercad and they're ready to go. So I'm going to do something here kind of incorrectly on purpose, or not incorrectly, but inefficiently. And what that is, I'm going to take this triangular surface and drag it over. And what you'll notice is it'll rest on the work plane. Now, I know that I want my triangular prism to be up here. So what I could do, like I said with my black arrow, is I could climb it up by a height of 190. But if I was to repetitively do that as the complexity of the model increases, it could be hard to remember measurements or whatever. So instead, what I'm going to do is I'm going to move the work plane. And what I'm going to do is by clicking my work plane button here on the right hand side, that activates your work plane. And what I can do now is I can select any surface that I want to fix it to. So if I put my work plane on the top of the carton here, I can now take my triangular prism, drop it over, and at least it's at the right altitude. So I'm going to zoom in now, and I'm going to change the measurements of this to suit the carton. So it's going to be 70, and it's going to be 70 in the other direction as well. And then if I just check my little worksheet, the perpendicular height of that is 25. Okay. Now, if I just hold it down with the left click, I can move it into position. I kind of will be eyeballing it a little bit. So what I think is useful is if I use my viewing cube here to line it up. And remember, I switched to orthographic, a flat view at the beginning, so there's no perspective being applied here. So if I switch here to my front by just clicking on it and I toggle up, I'm happy enough with that. And if I switch to the top view, again, I'm happy enough with the way that's lining up as well. Yeah, so I'll take that. And I'm going to go back now to a 3D view just so I can continue modeling. The next thing I'll do is I'm going to put the little lip on the top. So I might do this the other way now. Rather than making a new work plane, I might elevate it up from the one I have. So if I go back up here, I'm going to select a box again. And I'm going to put a width of 70 on it. And the thickness is quite narrow. I didn't measure that on my worksheet. I'm just going to measure it now. So the milk carton thickness is about maybe 1.5 mil or 2 mil. So I'll set it to 2. And then the perpendicular height of that little flap at the top, if I remember correctly, yeah, let's check, is 10. Okay, so what I'm now going to do is I'm going to elevate that up by the height of the perpendicular measurement on the triangular prism. So that was 25, if I remember correctly. And then I'm going to use my toggle my view so that when I bring it over, it lines up a bit where I want it. Now, you could, there's loads of other features on Tinkercad, we just won't go into them tonight, where you can actually align the different objects so they're centered with each other. And we might look at that at a later date. This is just to show you basic modeling. The last bit of modeling that I have to do is the cap, and it's a cylinder. Now, the cap rests on this angular surface here. So I'm going to switch my work plane to that, like so. I'm going to take a cylinder, drag it over. It's resting on it like so. And now I'm just going to change my view so I'm looking at the cylinder more head on. And the diameter was 30. What you find is when you change one measurement on a cylinder here, it'll actually go elliptical in shape. So just don't forget to change the other directional measurement as well. Okay, I might just need to twist it around a little bit to change that last measurement. Yeah, 30. And then the height of the cylinder, just check it now, is about 12 mil. So I'll change that there to 12. And that's me happy with the height. The last thing I want to do is I'm just going to center it up. Okay, so that's my milk carton modeled. The next thing I'm going to show you is to just very quickly change some of the colors. So what I might do is, before I start messing around with any colors, is put my work plane back on the ground that we started off with. And then what I'll do is I'm going to select the different bodies that as I built it up, starting off with my my square-based prism. And I'm going to change the color just by clicking this button here. So I'll go with a kind of a dark color, blue. And I might put the triangular prism maybe in a white color. And that means I can put the cap in blue. And then I'll put the little lip at the top in blue as well. Okay. Now, that's the modeling finished. One last thing that I'm just going to show you is, and this might be something that students might get frustrated with, if I wanted to pick up that carton and move it, at the moment it's 4 individual parts. So if I clicked any one of those and tried to drag the entire object away, only the individual part would move. So what we can do is we can just combine them all into one solid. So to do that in Tinkercad, you just hold down your left click and drag it over the entirety of the object that you're modeling. You can see here it's highlighted that there's 4 shapes there. And there's a button here on the top which allows me to group them. Now, there is a shortcut you can use on your keypad as well, Control and G, but I'm just going to use the button for now. Now, what you notice is when I click that button, the entire object goes one solid color. But you don't need to worry, you haven't lost any of your work or you won't have to redo it. What I can do now is click down on the arrow here to where my color is. And if I click the multicolor button, it'll revert back to the original combination of colors before it grouped it. But now it's all one solid object. So if I pick it up and move it around, it'll all come in the one go. So that's kind of some basic modeling. The other guys have been working on stuff today, and we're going to have a look at what they've been doing in a moment. But before I go out of this, I just want to show you a nice feature which can often cause problems with students, is they might forget to save their work or whatever. Because it's cloud-based, this is actually auto-saving all of the time. So what's happened is Tinkercad will generate an automatic name for your file. It'll be quite random, as you can see. So if I want to change that, I can just click the button here and it'll change the file name. I won't bother with it right now. So if I just go back to my interface, my dashboard, hopefully my milk carton will be there for me to view, along with the other objects that I've done over the past day or so. And you can see it loading. Yeah, so it's there to view. So that's maybe something that you could get students doing, taking an object, deconstructing it. They're doing a bit of sketching. They're thinking in terms of 3D geometry, how an object could be constructed, or how they could break it up into solids that they're familiar with, and then going to CAD with a lot of the thinking done. And they could use that then as a kind of an instruction manual, or some sort of a kind of a step-by-step way of building it up then through the CAD model. The next thing, we're just going to go back to my presentation now. So we have looked at Tinkercad and we have created something in 3D. We've edited the sizes, we've changed the working plane, we've combined the shapes together, and we've added color. So we've a lot done there. Now there's a load of other stuff you could do with Tinkercad, and we may look at that at a later date, or I'm sure, as was often the case, students might outpass a lot of ourselves very quickly on this sort of stuff. So they might just kind of snowball effect and take off. But we look at a lot of that stuff maybe at another time. What we're now going to do is we're just going to shift direction slightly and do something different away from, let's say, the modeling software. And we're going to use a digital technology, something that I presume most people have because I've been doing the presentation this evening, and that is PowerPoint. And there's a nice feature in PowerPoint which is called PowerPoint Draw. So what we thought would be a nice little kind of extension task after a student has modeled something on Tinkercad, if they just took screenshots of the object using, if you remember me toggling the cube earlier on, where I was able to look at the different sides of it. And this is just one that I prepared earlier on, where I maybe looked from the front, the top, and the side. And I just positioned them on a PowerPoint template so that they mimic what maybe the orthographic projections of the object would look like. A nice feature on PowerPoint, though, that we found is the PowerPoint Draw function. So I'm just going to show you that now. So before I actually start into it, some of you may have it already, but a lot don't. I didn't have it until I actually added it in. So you'll see here on my PowerPoint interface, there's a Draw tab here. If you don't have that, it should be in PowerPoint if you have the most up-to-date one. So if you right-click on the ribbon up here, just in empty space, and you click Customize the ribbon, you can add in the Draw tab if you haven't got it ticked, and press OK, and it'll come up then. So what's nice about it is it's developed on quite a bit since its maybe initial version a couple of years ago, and the addition of the ruler really kind of steps it up. So this just may be an alternative. Maybe we heard a lot of teachers saying maybe that the students haven't got drawing equipment at home. So this may be just something that they could do as a stopgap in the meantime, just to keep them in tune with how board drawings will be done. So if I click my ruler here, you'll see it popping up for me. So I can move it around just by clicking down with the mouse and hovering it around the screen like so. And you'll see here in the middle, there's an angle that you can set. So to change that, I use an external mouse. So if I just use the wheel on the mouse, it'll change the angle like so. So I can set it to horizontal like so. And that's what I would have used to draw my XY line in this case here. So my drawing tools are all up here. The pencil is quite useful for drawing construction lines, and then to go over your finished lines, you might use maybe a black or a heavier color. What we've done here is we've just taken an object, you're kind of, the stuff we're familiar with, maybe starting off early days with orthographic projection, where it might be the kind of the block objects, if you want to call them that. And we've taken the screenshots, like I just talked about with the milk carton, but we've left one out. So maybe a little extension task for students might be to complete the third view using the kind of guide measurements that they could off their views, and if they cross-reference them off each other. So for instance, I'm just going to complete that now. So this will take maybe 3 or 4 minutes to do. So I'm going to switch to a 45-degree angle. I'm going to put my ruler down here, go to my construction pencil, and if I just drag the pencil along the ruler, I get a nice straight line at 45 degrees. So you'll see now if I pick up my ruler and move it away, I have that angle line to work with. So what I'll do is I'll just bring the references from the plan view over to that line, and I'm going to draw on my pencil again. Sorry, I actually clicked pen by mistake there, so go back to my pencil, draw my line, drop my ruler down, bring a line over here, and then down towards the bottom, and a line over. Then I'm going to switch my ruler to 90 degrees, bring those measurements up, again all construction lines. And then the last thing I'll do is I'll go to my elevation and I'll bring the heights over. Probably could have done that a moment ago when I had it at 0 degrees. So I bring the overall height over and my pencil is active, yeah. And then I'll bring this reference. Okay, and I'm just going to finish the drawing by completing the end view by drawing in my finished lines. So I go to 90 degrees again. And again, you could be as kind of careful, and you could zoom in on this to get the minuteness of the accuracy on it. Just going to go through it rather quickly just for demonstration purposes. And I have 2 more lines to draw. Now, the next thing I want to show you on this, which is quite a nifty feature, I remember having to do a lot of PowerPoints where we might like to animate the lines. So I'm just going to get rid of the ruler there. There's a feature in the Draw tab, which is Ink Replay. So what I've just completed live there is that drawing using the construction lines and then going over with the finish lines. What PowerPoint has been doing is it's actually been tracking that line, those lines in the order that I drew them. So if I click the Ink Replay button, it should give me an animation of that, like so. And it's just a nice little feature. So again, kids might like to show that's how they completed their drawing, etc. Or even for ourselves as teachers, for different areas that you might be studying, you might like to animate drawings like so. This is just an alternative to that, or maybe an extension of it, where we've taken the orthographic views and we've drawn an isometric view, again using the ruler and the pencil and the pen as a guide. So I'm just going to click the Ink Replay button on that, and you can see the order in which this was drawn. Again, the construction lines, and you'll see the finished lines coming in as I speak now. Okay, so that's our kind of Tinkercad modeling, and then progressing it into a board drawing type-esque thing with the remote learning features that we've just shown on PowerPoint. We are going to go next to a teacher demonstrate or teacher tutorial on what they've been doing with Tinkercad. But before we do that, we might just check back in with our class group. So I'm going to go back to my class here. And if you remember at the beginning of the webinar, I mentioned that I had one set up earlier on today. So if I click into that and I look at my students from earlier on, I can click in. So let's say Thomas Boyle here. And we'll see what Thomas has modeled over the last few minutes, and we can see that he's modeled a wrench. So that's what the teacher is going to see. They can click into all their students and they can see the object that they've modeled. If I click in View in 3D, I can rotate it and move it like so. And I can also continue to edit it. So if I want to copy and tinker it, I can click that button and continue to actually look at the more minuteness of the model. There are features here in the download tab, but actually our teacher that's going to talk in a moment is actually going to talk about that. So there's no need for me to go on about it. And I'm going to go back out here to just check on some of the other students that were doing stuff. So John Kilgannon, for example, as I mentioned, is answering some of your questions in the background. So earlier on today, John would have modeled up this Tipp-Ex bottle, again, using those kind of basic 3D shapes to build up the geometry of it. So that's how you could take kind of everyday objects, etc. Now, what some of the advisors have done is they've just looked at maybe linking it into other subjects as well. So any wood technology teachers that we have out there tuning in, and if you were at this year's CPD event, the core day, you would have participated in an activity around a design task to do with a catamaran type project. So Declan here has just modeled up a kind of prototype of a solution to that design task that wood technology teachers would have looked at this year. So again, just using Tinkercad to do a bit of thinking in 3D and to model up like so. And then the next one that I'm going to show you is a different direction altogether for Tinkercad. And this is look at the model that was done by Gary Crossan. So you'll see here when I click into Gary Crossan's profile, there's nothing here in terms of 3D designs. But there's also another area that we haven't looked at tonight, again, we might look at it in the future, is circuits. So if I click into circuits under Gary Crossan's profile here as a student, you see that he actually has completed some sample circuits. So you can model that on Tinkercad as well. So if I click into this, what I now see is rather than view in 3D, as I was looking at earlier on with the other students, there's a simulate button. So if I click that, I can see what type of a circuit Gary was trying to simulate or prototype. So again, if I click start simulation here, you see here that we have a battery powering and we have a little cog turning around. If I turn on my switch, you'll see that it's slowly beginning to turn, and I'm just going to zoom in on that. You can see it's turning at 4 RPM. So also here we can see that if I adjust here, that's going to speed up. So if I zoom in now, it's up to 37, and again it'll go up exponentially as I increase that. So again, we can use Tinkercad maybe in a cross-curricular way. Does other things apart from just modeling in 3D. It has that capability with the circuit feature as well. So I'm just going to click off my switch here, and it should cut the power, and it does. Very good. So that was Gary's, just looking at the circuits. And then we might just have another look at one more. So we have, I think Fintan was working on something earlier on, 3D model of tea light. So nice little kind of object maybe that was on the mantelpiece or whatever, and then also using the text function here to build up 3D text. So what you see here is, as I was checking all those students, their profile pictures were blue. What that means is, as a teacher, when I'm checking my class group, when those go blue, it just means that the student has actually logged in or has actively been modeling something. Whereas if I go to my my dummy class that I set up at the beginning of the webinar, you see that the profiles are gray. So that means that those students haven't logged in. Okay, so that's where we are in terms of the tutorial part of this. As I said, one of the highlights of this webinar for us was getting the kind of information from Kieran. And this is just a very short video that was put together by Kieran, which showcases what his students, his first year graphics students, have been working on for the last couple of weeks since they've been at home. So I'm just going to switch over audio now so the video plays, so just bear with me for 1 second.
This assignment was based around using Autodesk Tinkercad in a first-year graphics classroom. They were given a link to a very basic how to create a key tag on YouTube video, and they had to design and make their own key tag based on what they had seen. Tinkercad Classroom is an excellent resource. It allows you to create a digital classroom for each of your classes. Here's one I've created earlier. When I click in, I have my class list and the usernames that I have assigned to my class. My class can access this using a code, and I can then look at the digital work presented by my students. For example, this is one of the boys' attempts at the key tag. By scrolling my mouse, I can have a quick orbit of what it's like. By clicking on it, I get this preview window. Again, I just get a 3D view of what it's like. If I click on the view in 3D, I now have an option to look at it, to choose the orientation cube and pick which side I want to look at. Might be of interest in terms of teaching orthographic, which I have yet to do given the current COVID-19 circumstances. And by clicking and dragging in the window, I can get a free orbit similar to what we would be used to using SOLIDWORKS. I have two options in the preview window. I can copy and tinker, which means that it will open that up, that I can look at the different parts the child has used to make it. So here we are looking at the workspace view. This is the digital equivalent of the drawing sheet for the child to work on. It's the equivalent of the plane that you'll be familiar with in SOLIDWORKS. There are the usual tools such as the view orientation. We can also select the various parts, change the color, change the material, change the sizes or the orientation as we decide we want to do. The second option in the preview window is the download option. This is very convenient for a student to output their work, for example, as an STL file that they can then import into the slicing software to use for a 3D printer or similar manufacturing process. Given that this was the first year's first opportunity to use CAD, many of the designs were very basic. However, we were getting across the basic idea and the notion of building up a complex part using features such as bosses, bases, cuts, extrudes, and other shapes. You can see from the few examples, some of the girls in particular went to great lengths to add detail to their pieces by adding numerous features to improve their design. It was very encouraging to see some of the students who, having watched the tutorial video on YouTube, came along and made up their own designs using their own geometry and their own taste. For example, this is a keyring by Rebecca, and she has come up with the base geometry completely by herself. I'm just going to click on Copy and Tinker to open that up in my profile from Tinkercad Classroom, and I'll be able to see exactly how she had set that up on her work plane and the different features she used to build it. I'm just going to zoom in here that I can have a look, and by clicking and dragging, I'm going to orientate the workspace so that I can see exactly how she has done it. Again, I could use the cube there to pick the various views. Again, for a first year, this is an exceptionally easy and intuitive way of introducing them to the concept of a 3D workspace and the various views that can be obtained. When I posted this assignment on Teams, I informed the class that the first 5 that were finished, I would 3D print and post home to them, just as an incentive. So I'm just going to download Rebecca's STL, and when I load that up in the software for slicing that came with my Cindo 3D printer, I'm going to just open this up, and I should have her workspace and her object replicated on the build plate for my Cindo. There it is. And now I'm able to take that, and just to show the students, I took a video of the slicing performed by the software so that the 3D printer can replicate that model that was built in 3D virtual space in the 3D real world space. Linking the manufacturing process with Tinkercad in this manner proved to be a very, very effective strategy. Not only did the students get to see their work being made in reality and get to see the manufacturing process behind 3D printing, or rapid prototyping if we give it its proper term, but also it joined together the importance of graphics in terms of product design and in terms of manufacturing. Using Tinkercad Classroom this way helped the students obtain the sense of achievement that comes with getting things done, and also the understanding of how graphics relates to the manufacturing process and design, and that the concepts and constructions learned in the DCG room have a relevance to objects in the real world. Tinkercad Classroom provided me with the digital equivalent of a folder for the students with all their work inside in it, and the ability to look at each individual student's folder and each individual component that they had made within that folder. It was a highly effective learning tool.
Okay, so that was Kieran, and again, we just would like to thank him once again. It's been really great kind of bringing this to our attention and that we're able to share it with teachers nationwide. And we'd also like to thank the students who are partaking in that as well, up in, I think, Cavan Mountain direction. So thank you very much for that. The closing few minutes now, we'll be coming into John in a couple of moments. If he's going to share in any kind of questions that are coming in, or if there's any kind of tips, again, you can get them in the last couple of minutes. But just another thing that we've been looking at for the last few weeks is the JCT4 Remote Learning Challenges 2020. So we started these just towards the end of March in response to the situation that was unfolding with schools and students having to work from home. So just to give some kind of help there to teachers in terms of different things that students could be doing remotely. So those challenges have been really kind of heartening. We've loved seeing the work coming in from students. They're in the resources section of the website. I might just show you where that is in a moment. And if you would like any of the work profiled or shown, we email it out every Friday. So you'll see at the end of the PDF document the details of how to send that in to us. These are just some of the student responses in terms of those weekly challenges, and I'm just showing them across the 4 subjects here. And this is just a kind of a taste of stuff that's been coming in. It's been brilliant, and they're coming thick and fast every week. So again, we have a lot of teachers sending them in every week to us, and we have some new people sending them in as well. So if you'd like to get in on that, we'd love to see it. Of course, this webinar is in the context of a cloud-based workshop that we were going to do, an elective workshop towards the latter end of this academic year, but unfortunately we weren't able to proceed with that for obvious reasons. So just to make you aware that there is plans in place to reschedule this, and we're working on alternative dates, but as I'm sure you can all appreciate, it's a very live situation, and we'll obviously be adhering to advice that we get on it. So more than likely it'll be the start of the next academic year at least before those elective workshops are able to take place, and any future ones as well. So if you bear with us with that, and if you make sure just to be joined up to our mailing list, you'll be the first to hear about the alternative dates whenever they do come to pass. So what I might do now is I'm just going to bring John in a moment, but as I said, I might just go to the website very quickly just to show you where those weekly challenges are, and also to show you some resources that are up in the sections as well. So if you go to the technologies section, I'll just show you the graphics one, given that it's what the webinar is about tonight, but you'll find it for all of the JCT4 areas, the technology subjects. So if I go to resources, go to graphics, and you'll see here we have the 5 weeks of challenges up. So if you click and download those, you'll get the full suite of challenges across the 4 subjects. You'll also see in the resources section, we've uploaded some classroom resources that you would have seen as part of maybe core days or previous webinars. And you'll see those resources available for download, as well as planning documents, a digital planning tool, and kind of advice on use of professional time, etc. So you'll find all of that in the resources section. Tonight's webinar will also be hosted on the website, and it'll be in the CPD workshops section. So if you go to CPD workshops and go to graphics, you will find this year's core day as the default. And if you go to the left-hand side of the screen and click on elective workshops, webinars are hosted here. So there'll be previous webinars along with associated resources there. And like I said, tonight's will go up there over the next couple of days. So what I'm going to do now is, and I've just been promising for a while, and we're just in good time. We're going up to about 25 past now. So I'm just going to bring in John Forrest now. So just bear with me while I get John's mic to come on. So hi, John, are you there?
Yeah, can you hear me?
Good man, yeah, all the way from Cork, good man.
Very good. So look, thanks, Michael, and good evening, everyone. And again, hope I'm coming in loud and clear for everyone. First of all, I would like to thank all the teachers for the high level of engagement with the webinar tonight. there's been a massive amount of questions and great examples of what is working well for teachers and some good tips and tricks as well. So a lot of the examples have been shared through the chat function of the webinar this evening. So what I'm going to do is I'm just going to start off by answering some of the main questions that are coming in this evening. So I think, Michael, you have answered the first question. Can I access this webinar at a later date? And the answer there is yes. As Michael's shown there, you can access it through the elective sections of the graphics website on www.jct.ie. The next question is in relation to the weekly challenges. How long will the challenges be continuing until? So the challenges will be continuing until Monday, the 25th of May, which is 2 more weeks of challenges. And the next question then is, how do we get students' work displayed for the weekly challenges? So the weekly challenges need to be emailed to Michael Lynch, who compiles all the student examples across all the technology subjects. This information can be found when you open the PDF of the weekly challenges, and on the last page you will find email details of Michael Lynch. His email address is michael.lynch@jct.ie. And the last question is, and it's come up a nice bit tonight, is a practical question. What visualizer is Michael using? So Michael is using the Hovercam Solo 8 Plus for tonight's webinar. The team are working through the questions in the background, so if your question hasn't been answered yet, we will endeavour to do so before the end of the broadcast. The team will continue to answer questions up till the end of the webinar. Any questions that are not answered live tonight will be sent out to the email you registered with for tonight's webinar. I'm now going to move on to some of the examples that teachers have shared with the graphics team. It's great to hear about all the different approaches that teachers are using to engage their students at this time. Here are just a sample of the examples that are coming in. We've just one example in here. What I find is working well is setting up my phone as a visualizer. I saw an example online of how to set up my phone using a wooden support, which I could easily make. This works quite well, and I just explain live as I'm doing it and forward it on to the class. Sometimes I may have to video edit, and I use Shotcut, which is a free software. Another example here, I have used Tinkercad Classroom and have got excellent engagement with the students. It has increased the percentage of students engaging and has translated to other engagement in the subject. This another example coming here from a teacher. I find the snipping tool a useful method of developing content, especially that is inbuilt into most laptops, as Michael shown earlier on. I also get my students to use the snipping tool to send me material and work as well. And just one last example in here from Paul in relation to the PowerPoint draw function. You can also do the drawing in notes and on pictures in iOS. Select the markup icon, looks like a pencil tip, and he said it's very handy for correcting students' work.
Very good.
That's just some of the examples that are coming in there. Again, I would like to thank the teachers for engaging with the webinar tonight and sharing some of the great work that's happening across the country. So I'm just going to pass it back to you there, Michael.
Thanks a million, John. And look, I won't labour it any further. It's been great to go through it this evening, and thanks to all. It's one of, I think it's our highest attended webinars, over 250 teachers tuning in, which is a lot of people looking at a screen at the one time. So thank you very much. We appreciate it. And like I said, any kind of support that we can help with at all, you can get in contact with us, info@jct.ie. And as John mentioned there with the weekly challenges, if you'd like to send them in to myself, you'll see the email address at the end of the document. So thank you very much, folks. I'm going to leave it there. Like John mentioned, if you have an outstanding question that maybe the lads haven't got a chance to get back to you on, I'm just going to leave the webinar active for a couple of minutes, 5 or 6 minutes, and they may get back to you. If they don't, there'll definitely be an answer within the next day or so. So thank you very much and all the best.